Okay, welcome back. This is the 14th lesson of grade 11. This lesson is about equiangular triangles. Okay, the first part we'll be studying about ratio, something with ratio. Okay, this is what. Now, say you have a line. Say you have a line AB. This line is somewhere on the line. You have a part called D also. Okay, a point D is also there. We'll say you have this is equal to 3 centimeters, AD is equal to 3, and from D to B it is equal to 7 centimeters. Okay, now you should know how to write it in the ratio. Okay, the ratio form, that is the length and the value. Okay, listen here. I'm going to write the ratio between AD to DB. Okay, you can say these two lengths. If you find the ratio of these two lengths, you can write what is the length of this. Yeah, 3 is to 7 centimeters. Ratio, you also should know that ratio is always written in the smallest form. Okay, one more example. Say you have AB, you have G here. So you have 2 centimeters, AG is 2, and here you have 14 centimeters. How do you write in the ratio format? Yeah, AG is to GB is equal to how much? First you have to write 2 is to 14, and then you can simplify and write divide by 2, 1 is to 7. Is that clear? Okay, the same thing. Okay, now this same thing can be written as ratios, can be written in fraction form. That is, you can write AG over GB is equal to, what are the two values? 1 over 7. These things are important in order to learn this lesson. Is this clear? Okay, you can write in this form also, in fraction form also. Okay, now for this let us first consider a triangle. Okay, say you have a side of a triangle. If you just consider one side of a triangle, it is also like a straight line, right? Okay, now we'll say here you have P. Here we'll say this is equal to 3 centimeters, this is equal to 10 centimeters. Now if I ask you what is AP over PB, how do you write? Yes, it is 3 over 10. Is that part clear? Okay. Now there is a theorem you should study. The first theorem in this lesson, the first theorem, that is, if you take any triangle. Okay, let me take a triangle that is something like this, A, B, C. Okay, now say there is a line parallel to one of the sides of a triangle. To this side we draw another line, there is another line, these two are parallel. I'll call this as P and D. Now when there is a line which is parallel to one side of the triangle, these two sides, now this length and this line, there is a ratio, right? Okay, these two sides, the ratio, and these two sides, the ratios are always same. That is what you mean by the first theorem. Understand? In any triangle, if you draw a line parallel to one of the sides, okay, then the other two sides, the ratios are equal. Is that clear? Okay, you have few questions to solve here. So you can say a line drawn parallel to a side of a triangle, divides the other two sides proportionally. That means this fraction and these fractions are equal. Fraction form. Okay, the two ratios are same. Understand? Clear? Okay. Okay, an example. Okay, you'll understand the meaning of this in the next example. Okay, that is, let us consider this triangle. I'll call it A, B and C. you have a parallel line drawn this way. These two are parallel. The information they have given is this is equal to xy, and this length is equal to x, and this is equal to 2 centimeters, and this is 3 centimeters, and this is 15 centimeters. The only information they have given is that this is parallel to this, and these are the lengths. You have to find the unknown length x. How do you find out? I told you, in a triangle, if they have drawn a line parallel to one of the sides, then the ratio of this side and this side both are equal. Now how do I find the ratio of this? Okay, you can say ax over xb is equal to 15 over 3. Is that clear? Yes. Now take the other side. Take the same ratio, that is, call it this as 1, and this side I'll call it, okay, ay over yc. That will give me x over 2 centimeters, that is second. Since using the theorem we studied, you can say 1 is equal to 2, that is 15 over 3 is equal to x over 2. Now you have to cross multiply. Don't forget the units. Okay, cross multiplying will give me 15 centimeters multiplied by 2 centimeters. Yes, divide by 3 centimeters. 5 times 2, 10. The answer is 10 centimeters. Understand? These two fractions or the ratios are same. This is what you mean by this theorem. Okay. Okay. And then let us take one more question. That is from page number 82. Page 82. Page 82, question number 4. Here a triangle is given. Let's try to solve everything on this page. We call this as ABC. Okay, the information they have given is that these two lines are equal. This is EG, and yeah, there is a line drawn this way. This is, we'll call this D. This line is also parallel to another line drawn this way. These two are parallel. Is that clear? Okay, these two lines are parallel. DG and FC are parallel, and also EG and BC are parallel. Okay, in any triangle you can use that theorem I told you. If two sides are, if a line is drawn parallel to the third side, one of the sides, you can put the ratio theorem and use the theorem. Understand? Okay. Also they have given certain values. This is equal to 18 centimeter. This is equal to x, and also here they have given this as 6 centimeters, this as 4, and this 5, and this is y. Now how do you solve? Okay, observe. First I'm going to consider triangle AFC. Now if you consider AFC, see, this is the one of the sides of a triangle. This line is parallel to one of the sides, right? Therefore in triangle AFC, since these two sides are parallel, I can say that, yeah, the other two sides, they are in the same proportion. The ratios are equal. Therefore I can say AD over DF is equal to AG over GC. Is that clear? Yes. That will give me AD is how much? Yeah, 6 centimeters. DF is equal to 5 plus 4 is equal to 9 centimeters. Okay, this total length 5 plus 4 is equal to 9 centimeters. AG equals to X, and GC is equal to 18 centimeters. Now can't you find out X? It's easy, right? Yes. In order to find out X, you cross multiply. Equal to 6 into 18 divided by 9 centimeters. So 1, 2, x is equal to 12 centimeters. Now already you have found out x. Okay, now let us consider a large triangle. Okay, in triangle ABC, if you consider the larger triangle, there you get both y and x also, na? Okay, I'm going to take, okay, if you consider the larger triangle, which side is parallel? EG is parallel to BC. Therefore, this is the proportional line. This line cuts both the sides in same proportion. Okay, therefore I can say AE over EB is equal to AG over GC. Okay, now let us substitute. AE is equal to 10 centimeters over EB. What is my EB? 5 plus y is equal to, what is my AG? X you know it. Yeah, it's 12 centimeters over, what is GC? It's 18 centimeters. Now can't you solve? It is possible, right? So you make this as the subject, cross multiply 10 into 18 divide by 12, that is equal to 5 plus y. Okay, you have centimeters. This is also centimeters. Okay, therefore if you solve, you get you can divide by 6, 3 and 2, here 5, 15 minus 5, y is equal to 15 minus 5 centimeters. Y is equal to how much? 10 centimeters. Is that clear? Okay, this is not hard. You just have to say that the ratios are equal. Understand, the ratios of both sides are equal. Is that clear? Okay, next let us check, let us discuss one more question, that is on page number 84. On page 84, the second question, that is, they have given you a diagram, okay, and certain things are given, datas are given. These two are parallel. Okay, all these three lines are parallel. This is ACE, and then you have BDF. The data given are based on the given information in the figure. Prove that. Okay, you have to prove AC to CE ratio is equal to BD to DF. Okay, now how do you prove? Now all this time we studied about triangles, right? Okay, since we don't have a triangle, let us make a small construction. I will say construction or whatever. Join. Let us join this AF or BE. Okay, I'll join AF so that it makes a triangle, isn't it? Yes, it makes a triangle this way. Is that clear? Okay, I'll call this point as X. Okay, now let us consider the triangle AEF. Okay, so we'll say in triangle AEF. So this triangle. Okay, the things are this. Now already, since they have marked this and this as parallel, according to the theorem, you can say since CX is parallel to EF, according to the midpoint theorem, according to the state it, and then you can say, since these two lines are parallel, you can say that this line cuts the two sides of the triangle in the same ratio. That means you can say AC over CE is equal to AX over XF. This is one equation. Now you have got this part, AC to CE. Now where is BD and DF? It's on the other side, right? Okay, now what we are trying to do here is this. Now we have already brought this into the equation. Now you have to take the other side. Now what I'm going to do is I'm going to take this triangle, and then using the midpoint theorem I'm going to write the same ratio, and then you can bring a relationship between these two sides, okay, by equating both to ax and xf. Clear? Okay, if you're not clear, just listen. Okay, this is the way. Now you have to take the other triangle, that is ABF. Now in ABF triangle, this and this are parallel, right? Therefore you can say AB is parallel to XD. Okay, and one thing we studied, that if in a triangle, if a line is drawn parallel to one of the sides, it cuts the other two sides in the same ratio. Therefore these are the two sides, BF and AF, so it cuts in the same ratio. Therefore I can say in that triangle, according to the theorem, you can say AX over XF is equal to BD over DF. Is that clear? Okay, now you have brought the second equation. Now see, both these parts are equal to AX over XF. Therefore, since 1 and 2 are both equal, that is going to give you AC over CE is equal to BD over DF. So you can write this in the ratio format. AC to CE is equal to BD to DF. Is that clear? Okay. Okay. One more example, that is think of a diagram this way. Okay, we have to, yes, okay, before that we'll come to the theorem. Okay, now what is the theorem we are going to study? Well, you have the converse of this theorem. Is that clear? Now you have studied the theorem, right? You have a converse of the above theorem. That is if you take a triangle, consider a triangle ABC. Okay, converse of the theorem. Okay, now what we are going to do here is, it is bit something you come from the other side, the same theorem but you come from the other side. Earlier also you have studied something related to this. Okay, now here they say, if a line divides two sides of a triangle proportionally, then that line is parallel to the third side. Now what did we study all this time? When we draw a parallel line, it divides the other two sides in the same proportion. Now if a line divides two sides in the same proportion, then this line is parallel to the third side. Okay, are you clear with this? Okay, so yeah, you can use whatever. That is the theorem. Okay, now let us see how to solve a main question using this theorem. It's not hard. Okay, an example, let's say, okay, take this for an example. ABF, say you have, okay, DF, and here you say, okay, this is X, here 3 centimeters, this is 9, this is 21, 7. You have to find AX is to XC. How to find? Okay, now observe, you have to find the ratio between AX to XC. This is E. Okay, now to start with, I'm going to consider the triangle ABF. Okay, therefore I'll say in triangle ABF. Okay, if I consider ABF triangle, okay, can you see that there is a line which cuts the two sides of a triangle? Now let us see whether they are in the same proportion. Okay, then I'm going to consider AD over DB. What is it? That is 3 over 7. Okay, also I am going to check the other proportion, AF over this is not F, let us consider this C. Okay, we'll check FC. You have 9 over 21. If you divide by 3, you get 3 over 7. Okay. Now can't you see that these two proportions are same? Yes, since those two proportions are same, now we can use the converse of the theorem. According to the converse of the theorem, you can say, according to the converse of the theorem, okay, you can say if these two are in the same ratio, this line, the line DF is parallel to BC. Is that clear? Now you have proved that DF line is parallel to BC. Now you can mark it after proving. Is that clear? We use the converse theorem and then found the ratio. Those two were proportional, were equal. That means the ratio of these two were equal. Therefore, I can say that this line is parallel to the third side. Okay, are you done with that? Okay. Now you have to find out AX over XE. Therefore, I am going to consider one of the smaller triangles. You can consider ABE or AEC. What shall we consider? Okay, I'll consider ABE. Okay, in triangle ABE. Okay, now if you take that triangle, since this line is parallel to this line, you can use the earlier theorem. Okay, since this line is parallel to this, since DF is parallel to BC, since DX is parallel to FC, using the theorem, if they are parallel, what can you say? If they are parallel, you can say that this line cuts the other two sides in the same proportion. That means AD over DB and AX over XE are both equal. They are equal. The ratios are equal. Therefore, AD over DF is equal to AX over, should be XE, right? Yes. It is DB, okay, XE. Okay, but you know the values of AD and DB. How much are they? Yeah, it's 3 over 7. 3 over 7. So you need only AX into XE. Na? Therefore, you can write, how do you write? AX to XE is equal to what? 3 is to 7. That's all. Is that part clear? Okay. Okay. Now since you know the converse of the theorem as well, let us move on to one more question. That is, okay, let us discuss one question from the book. That is on page number 87. Page 87, the third question. Okay, now you have to prove some things here. That is, the diagram is given. It's a bit complex diagram. Okay, you call the outer side as ABC, and also they have, yes, there is a midpoint here. They have joined all this. Also, yeah, these two are equal. Also this side also there is a line. These two are parallel, sorry, not equal, it's parallel. And also this side there is a line. They have not said anything about this. Okay, and they have marked all this with values. Okay, I'll call this as P, R, this, the middle part is X, and you have Q here. Okay, if you have to prove that QR, okay, according to the diagram, these are the datas given. You have to prove that BC is parallel to QR. These two lines are parallel. You have to prove that. According to my diagram, it is not parallel. Okay, you have to draw it neatly. Okay, okay, now you have to prove that those two are parallel. How do you start? First, I'll start from the datas given. The data is given now. Now you can take these two parallel. Now if a line is parallel in a triangle, you can use our theorem we studied. How do you start? In the triangle, you can consider the smaller triangle. In the triangle AXC, okay, if you say AXC, since this line is parallel to the third side, you can say that this line cuts the other two sides in the same proportion. Okay, so therefore you can say XR over RC. XR over RC is equal to XP over PA. XP over PA. Is that clear? Okay. Now what are the other data I can use? Also you can see that there is one more parallel line in the diagram. That is also a triangle AXB. Okay. Now I'll go to the other triangle. That is in the triangle. What is the triangle? AXB. Is that clear? Okay. Now from this triangle I'm going to use the same thing. Okay. Now here you can even say PR is parallel to AC, or using the theorem, all that. Here what are the two parallel lines? PQ is parallel to AB. Okay. Now since these two are parallel, this line cuts the other two sides in the same ratio. That means you can say XQ over QB is equal to XP over PA. Second equation. Now look here, both of these values are equal to XP over PA. Therefore using 1 and 2 you can say that XR over RC is equal to XQ over QB. Is that part clear? Okay, that is XQ to QB. Okay, these two are equal, right? Where is that? Yes, XR to RC and XQ to QB. Now you can use the converse theorem. Now look here, according to this answer, these two sides are in the same proportion. Their ratios are equal. Now what was the converse theorem we studied? Yeah, if the two sides of a triangle are in the same proportion, then that line is parallel to the third side. Therefore using the converse theorem, you can say that QR is parallel to BC. Is that clear? Okay. Next, okay, since we have finished this part, there is one more part that is not something related to this. It's a bit different. Okay, that is, we are going to speak about similar triangles. Now similar is the normal meaning. Similar means something that is similar to something. Okay, but there are a few things you have to understand here. Okay, now when you say similar triangles, there are two facts to consider. Now consider two triangles like this. Now look, both looks the same, right? But one is small, one is big. This is, let's say, ABC, and let us say this PQR. Okay, now these two triangles are said similar only if there are two conditions. Okay, one is that all the angles of this triangle should be equal to each of the triangles of the other. Okay, and also the sides. Okay, there are sides, now corresponding sides should be proportional. Okay, even if you don't understand, no worries, you'll be understanding it with these examples and questions. Okay, now see, two conditions. One is the angle should be same. This B angle is equal to I'll take Q, this angle. Okay, and I'll call one more angle. I'll say this A is equal to this angle. A angle is equal to P angle. And if two angles are equal to each other, automatically the third angle is also equal, should be equal. Okay, you know the reason, right? Because altogether if two are equal, the total should give you 180 now. So if you add both, the balance will be equal in both the triangles. Is that clear? Okay, now this part is done. Okay, now one more thing is that now you considered each of the angles, right? Now if you consider this double angle, there is a side opposite to it. Okay, now what we are going to do is we are going to write it. That is, I am going to consider this angle. What is the side in front opposite to that? That is BC. BC over, take the same angle on the other triangle. Now what is the side opposite to that? That is QR. That should be equal to, take another angle, this single angle, let's say, what is the side opposite to it? AC over, consider this triangle, what is the side opposite? That is PR, also equal to, what is this angle? Okay, the unmarked one. So opposite side is equal to AB, and here the opposite is equal to PQ. This is said to be similar triangles. What are the two conditions? One is that, yes, one is that each of the angles should be same, and also the sides should be proportional. Okay, but there is a special thing about triangles as well. Okay, before that we'll study what is the theorem under this. What is the theorem we are going to study under this? Similar triangles. Okay, there is a theorem. Let us check what is the theorem. The theorem is, if two triangles are equiangular, now if they say similar triangles, these are the two things that are equal. Each of the angles are equal, and also each of the sides are proportional. So if two triangles are equiangular, you can say then the corresponding sides are proportional. Okay, now did you understand a tricky part here? That is, you can say when this criteria is fulfilled, you can automatically say that this is also equal. That means these are in the same proportion. Okay, is that clear? That is a theorem. If in two triangles, if they are equiangular, okay, that means if the angles are equal to each other like this, if they are equal, automatically you can say that their sides are in the same proportion. Is that clear? Okay, now I told you there is an important part, a note for triangles. There is a special note. Let us check what is that note about. That is only for triangles. Okay, the word similar and equiangular both mean the same. Now you would have understood by the early example, both the same. Now I told you, if it is similar triangles, what are the two conditions? One is that angle should be same, and the other is that, yes, the sides should be proportional. Okay, now if you consider equiangular, that means the angles are equal. Automatically using our theorem, you also can say that the sides are also proportional. So it's the same thing repeated only for triangles. Keep this in mind. Okay, is that clear? Okay, now let us check one more question. That is, let's take one question related to this. Okay, equiangular. So you have two examples. One I'll call a small triangle this way, and the other this way. Okay, I'll call this A, B, and C. We'll say this is 8 centimeters, this is 4 centimeters, and you have 6 here. Okay, on the other side I have, let's say, PQR. This is equal to 15. This is X and Y. Now you have to find X and Y. Okay, also they have marked some angles equal. That is, they have marked that this angle with double line is equal to this angle. Also, this angle is equal to this angle. Okay, now automatically what can you say about this angle and this angle? They are also equal. because if two sides are equal, two angles are equal, automatically the third angle also will be equal to the other third angle. Is that clear? Okay, now what you can say is that, okay, you can say also that A angle, the angle A is equal to this angle, those two are equal. That is, are you clear with that part? Yes. Okay, now since these two are equiangular, you can say since the two triangles are equiangular, since they are equiangular, now we can move on to the theorem we studied. Using the theorem, you can say that what? Yes, their sides are also proportional. Now in order to consider the sides, this is the way you consider. Now now here I have marked, now there is a angle marked with one line. On the other side also you have an angle marked with the same line, right? Only those two are equal. Now if you take the double line, it is equal to this. If you take this unmarked one, it is equal to the unmarked angle. Is that clear? Okay, now what you have to do is take the double marked angle. What is that angle? Yeah, that is B angle. Now you have to consider the side opposite to it. What is that side? Yes, it is AC. AC over, now go to the other triangle, consider the same angle with double marked. What is the side opposite to it? Yes, it is PQ. That is equal to, now take, okay, yes, now you have taken PQ. Where is P? Yes, PQ you have taken. Is that clear? Yes, PQ you have taken. That means you have taken y into the equation. Now the next thing you are going to write here should not have x, because if there are two unknowns you can't find out. Now you have to consider the other one. What is the other one left? Yes, you have this 15 left. Therefore on the other side, yeah, the denominator should have the unknown, the unmarked angle, the side opposite to unmarked, that is QR. So this side, what is the side opposite to the unmarked angle? That is equal to BC. Now let us write the values. What is AC? AC is equal to 8 centimeters over what is PQ? PQ equal to Y. That is equal to, what is my BC? BC equal to 6. Also, what is my QR? QR is equal to 15. Now can't you find Y? Yes, you can. 15 into 8 divide by 6. Okay, so you can divide first by 2 will give you 4, 3, 5 times 4 is equal to 20 centimeters. Now you have found out Y. Now how do we find out X? Okay, in the same way, develop another equation such that you get X in the value. Is that clear? Okay, I'm going to consider AB over, okay, let me write that part here. AB over, I'm going to take, AB means it is opposite to which angle? The single line. So here if you take the single line, that is X. Okay, yes. Now you should take, since you have included X, you have to take these two sides with the known lengths. What is the known lengths I can take? Yeah, the one opposite to the unmarked angle. Then you have BC, that is equal to 6 over 15. So you have to make it the subject. That is going to give you, if you make X the subject, that will give you 10, I guess. So 15 into 4 divided by 6. Okay, 15 you have to multiply by 4 and divide by 6. That is equal to X. So here 2, 3 and 5 times 2 is equal to 10 centimeters. Is that clear? Okay, now since you have finished this part, let us go to the converse theorem of this. Now since you had theorems, you have a converse theorem of this part. That is, I'll write it here, the converse theorem. Okay, that is, now what is the theorem we studied under this? Okay, the theorem was, under equiangular triangles, the theorem was, if two triangles are equiangular, then the corresponding sides are in the same proportion. Okay, their proportion are equal. Now here, we will speak about the sides first. That means if the sides are proportional, then the two triangles are equiangular. Is that clear? Okay, that is, if the three sides of a triangle is proportional to another triangle, then the two triangles are what? Yes, they are equiangular triangles. Is that part clear? It is just the opposite. Now let us check one question based on that. That is, we'll check question number, we'll go to page number 98, and check the first question. Okay, the diagram is given. Okay, the diagram is given as this. Okay, let us move on to the next page. Page 98, first question. This is the diagram given. Okay, this they say BC, and also a side is parallel, a line is parallel, is equal to DE, this is equal to A. First you have to show that the triangles ADE, the triangle ADE and triangle ABC are equiangular triangles. How do you prove? Now since to prove equiangular, you have to prove each of the angles are equal. Now consider, since these two lines are parallel, you can say that this angle and this angle, the one I marked with a single line, those two angles are equal because of corresponding angles. And also these two angles are equal. What is the reason? Corresponding angles, because these two are parallel lines. Also the third side is anyway, the third angle is anyway equal. Or you can say, now consider the smaller triangle and the larger triangle. Both these triangles have A as the common angle, therefore anyway it should be equal. Therefore you can write in words and write the reason also. This B angle is equal to D angle. What is the reason? Corresponding angles. And also this side you have C angle is equal to E. Here also the same reason. Therefore these two triangles are congruent. Okay, now let us check the second part of this question. There you have to prove AD over DB, AD over AB is equal to DE over BC. Okay, now consider this part. Where is AD? AD is this part. Okay, now you can use our theorem. Okay, now you can write a sentence using the two triangles. You can say, using the triangle, what was the triangle here? ADE and triangle. See, now just look at the sides. You have DE and BC. Where is BC? You have to now consider the larger triangle. Therefore considering the triangle AD and ABC, considering this, what you have to do? Yes, bring a relationship using the theorem we studied. Okay, what is the theorem you are going to study here? It's about, first you are going to state that they are equiangular and then come to the sides. Then it is the normal theorem. Using the equiangular theorem, you can say that. See, how do you bring AD? AD is the side opposite to the angle I have marked with two lines. Therefore I can say AD is equal to, now go to the larger triangle. What is the side opposite to the angle I have marked with two lines? That is AB. See, almost I have got the answer. Now how do you take DE in my part? Yes, DE is the angle opposite to A. Therefore DE over, if you consider the larger triangle, you have to consider the same angle. Okay, therefore you have to take the side BC. See, you have got the answer, isn't it? Yes. What is the third question? You have to prove AE over ED is equal to AC over CB. Okay, even this looks simple. Okay, we'll see what to do here. Okay, now see, you have to first check where is AE. A is this side, that is opposite to which angle? The one I have marked with single line. Therefore here also you have to say in the two triangles ADE, you have to use the same sentence. Okay, AD and these two triangles, only those two triangles are equiangular here, no? So you have to just write only these two triangles here. Okay, and then write the same thing this part also using equiangular theorem. Okay, we are going to bring AE in our equation. How to bring AE? That means you have to consider this angle and the side opposite to it. Therefore AE over, now go to the larger triangle. What is the side opposite to this angle that I have marked with single line? AC. Now do you have AC here? No. AC somewhere here. We'll make a small change. First let us write AC. Now what are the other sides available? CB is available, ED is available. Where is CB? CB is here. Where is ED? ED is here. That means you have to consider which angle? Yes, you have to consider angle A. Then you have to, while considering angle A, you can say DE, they have say ED over, yes, if you consider angle A in the smaller triangle, you have to consider the same angle in the larger triangle, that is equal to CB or BC. Now from this equation, how do you get this equation? You have to cross multiply. AE over, yes, ED is equal to AC over CB. Is that clear? It's easy, right? So in this lesson we study few theorems. You have to directly use the theorem and then solve the questions all about ratios. Okay, you have ratios, you have to build up relationship and try to equate the ratios you have made. Understand? Okay, so for the further units, I'll be uploading videos. If you have not subscribed, subscribe the channel and then let others know. And thanks for watching.